Now that we've spent quite some time talking about how igneous rocks form beneath Earth's surface, now we're going to move to the top of Earth's surface and talk about igneous rocks that are extrusive. So at this point, you should know all about the different types of magma, including basaltic magma, which has the viscosity of ketchup. It flows very easily, creates shield volcanoes, versus rhyolitic magma. That's a much higher viscosity, think sour cream, and it forms those big explosive composite volcanoes. So basaltic is the low viscosity, rhyolitic is the high viscosity, and andesitic, that's the magma right in the middle. Okay? So once magma extrudes from Earth's surface, the shape of that resultant igneous body is no longer determined by how it's able to make room for itself beneath Earth's surface, and instead it's able to just explode onto Earth's surface, so the shapes can get a lot more random. As that magma explodes onto Earth's surface and becomes lava, the viscosity is going to increase, right? Because it's going to decrease in temperature, and it's going to lose a lot of the air bubbles. And this is going to cause these big explosive eruptions with a lot of fragmented material. And that explosive, solid, fragmented material that comes out of a volcano, we call it tephra. And this is an image of tephra, just to show you, it really is just a lot of different pieces. And when those pieces form together into a single rock, we call that rock a tuff. So a tuff is made from volcanic tephra. And you can see how all those little pieces of tephra shown in this tuff look very different, right? They're all just little fragmented pieces that are kind of random. So how explosive an eruption is depends on how much tephra there is compared to the amount of lava. You can imagine the more solid material there is, the more explosive a volcano is going to be, versus the more fluid the lava is, the liquid the lava is, the more flowy, the more calm that eruption is going to be. So we're going to focus first on effusive eruptions. These are the ones that are calm. They just flow. You're not going to see these huge eruptions, ash clouds, things like that. So effusive eruptions, they're more common with basaltic magma. Basaltic magma tends to be more mafic, meaning there's not a lot of silica in it. Because there's not a lot of silica in it, it has a low viscosity. It doesn't resist flow. It also can't hold much gas inside of it. So it just flows for long distances. So it's a low energy eruption, non-explosive. That does not mean it's not dangerous though, right? These lava flows can flow for great distances. And there is still gas released from the volcano that can be harmful to humans and other life. Now this is compared to explosive eruptions. These are the ones that are rhyolitic to andesitic. Remember, rhyolitic is the most felsic of the magmas, meaning there is a relatively large amount of silica. This increases the viscosity, increases the resistance to flow. So when it is forced to flow, it explodes. It also is able to hold in a lot of gas inside of it, a lot of air bubbles, which makes it more explosive. Think of like carbonated beverage, right? When you have gas within a liquid, it's more explosive. Now, these volcanoes, again, they're very dangerous when they do explode. These are going to have a huge eruption column and plume of ash and smoke. And depending on where you're at compared to the volcano, there's going to be a lot of hazards associated with that material, obviously coming out of the volcano and then raining back down to the surface. So this table is just a quick review of magma chemistry. Remember, we have three types of magma: basaltic, andesitic, and rhyolitic. Basaltic is the most mafic, low viscosity, low gas content, but also pretty hot. Then andesitic's in the middle. Rhyolitic is most silica, highest viscosity, highest gas content, but not as hot. All right, let's talk about these lava flows that form from these different types of magmas. So lava can be thin and runny or thick and sticky, depending on the viscosity. And remember, viscosity comes from many things, including silica, temperature, gas content. Basaltic lavas have low viscosity, they're runny. So that lava is going to flow for long distances and create a more flat volcanic feature. Rhyolitic lavas, they're thicker, they have a higher viscosity. And so they're going to kind of pile up right next to the crater of the volcano. And instead of creating a very wide volcano, create a very tall, skinny, more triangular shaped volcano.